All right, you guys, so here I'm going to show you how I simplify radicals. And this is an optional approach, an optional video. This is not anything that you need to absolutely do, but if you're struggling with simplifying radicals, this is actually something that I was taught by a math teacher who has gone on and retired, but I love the technique. Okay, so let's take the one example we had in our problem of the square root of 300. Okay, and how could I get 10 root 3 a different way, especially if I don't have I have not memorized my perfect squares. Okay, all right, so the technique I was taught was you use prime numbers. Okay, and your prime numbers, okay, they're divisible by 1 and themselves. So that's going to be 2, 3, 5, 7, 9, 10, 11, 13, 14, 15, 16, 17, dot, dot, dot. Okay, and the list goes on. But I'll be honest, it really hangs out, okay, in these first few values, okay? All right, so I'm going to take 300 and I'm going to divide by a prime number, and I'm going to divide in an upside down fashion, okay? And when I teach my students this for the first time, I say, okay, this is what we're doing, and I just say, hey, I need you to run division. And when I say run division, they know that they need to divide by prime numbers, okay? All right, so we're going to divide by any prime number that will divide 300, okay? So in this case, I can use 2, I can use 3, I can use 5. It doesn't matter which one. All right, so if I divide by 3, I get 100. Okay, now I need to take 100 and I need to divide by a prime number. Okay, I can't divide by 10. Okay, I know 100 is divisible by 10, but 10 is not a prime number. Okay, so I would try to divide by the prime number you had just used, but 100 is not divisible by 3, so I'm going to have to switch to 2 or 5. Okay, I'm going to divide it by 2, which is 50. I'm going to divide 50 by 2, which is 25. I'm going to divide 25 by 5, and then I'm going to divide 5 by itself, and I get 1. Okay? All right, and once you get to 1, you know that you have completed the division process. Okay? All right, so now I no longer need this part here, okay? But now I have these lists. I have a list of prime numbers, okay? And I'm going to get my answer from this list, okay? All right, so anytime I have a pair, I circle that pair and I make a note that I have a pair of 2s. I have one pair of 2s. I have a pair of 5s. So I'm going to write 5. Okay? That one pair of 2 times that one pair of 5. Well, what's 2 times 5? Okay, 2 times 5, that's 10. Okay, so what I tell my students is as they're working towards this process, what they would write down next, okay, when they got the square root of 300, I tell them, okay, you're going to write 2 times 5. So 2 times 5, okay, that's what's on the outside. And then on the inside, they're going to put all the numbers they didn't circle. Well, the only number I didn't circle was 3. So 2 times 5 is 10, square root of 3. And I got the same answer. Okay? All right, let me try again. Okay, so I wanted to simplify the square root of 12. Okay, so I'm going to take 12 and I'm going to divide by a prime number. Okay, so if that prime number is 3, I get 4. I'm going to divide 4 by a prime number, which is 2. 2, I get 1. Okay, then I'm going to circle. All right, and then I make a note of that. So that number goes on the outside, square root, because that's the only pairs I had. And then the numbers I did not circle goes on the inside. Okay, so my final answer is 2 root 3. Okay, let me try again. Okay, and the more examples that I do, the better that this gets. Okay, so I'm going to take the square root of 40. Okay, so I'm going to run division. I'm going to divide by a prime number, so 2, I get 20. 2, I get 10. Divide by 2, I get 5. 5, I get 1. Okay? All right, so I have a pair of 2's. I'm going to notate it. And then that's it. I don't have any remaining pairs. Okay? So I'm going to write this 2 on the outside, square root, and then the numbers I did not circle, I'm going to write inside the radical as a multiplication problem. Okay, so if you look back up here at 300, so see how when I had 2 pairs, I wrote it on the outside and I multiplied. Okay, and then when I did not have anything else, I just wrote the number. Okay, that same concept applies when I'm down here, and if I have 2 numbers left over, I multiply. Okay, but they're underneath the radical, so 2 square root 10. Okay. Now, if you're asking yourself, you're like, okay, I do kind of like this approach, but how do I check it? Okay. You type in the square root of 40 on your calculator. So you type the square root of 40. Oops, not 400. You get a decimal. Then you type in your final answer that's been simplified, 2 square root 10. And your decimal values should match. And if your decimal values have matched, you're at least on the right approach. You may not be fully simplified. Okay. All right. Let's do one more. Okay. And then if you've got additional examples that you'd like to show me or ask me to do, I'll be more than happy to do those. Okay. All right. So let me think of a good number off the top of my head. Oh, I know what I can do. All right, the square root of 125. Okay. All right, so I'm going to take 125 and I'm going to divide it by a prime number, which is 5. And then I get 25. I divide by 5, divide by 5 again, and I get 1. Okay. And it's okay that you have lots of 5s. Okay. You are only going to take the pair, one of pair, meaning 2 of them. Okay, you're going to make a note on the outside, so that's going to be a 5, and then you'll have a 5 on the inside. So this is going to be 5 square root 5. Okay, all right, so that's just one way that you can simplify a radical. If you don't like it, you don't have to use it. You can use whatever approach that your previous math teacher has given you. This is just something that I use and I really like it for future topics. Okay, good luck.